let us solve another LPP where we have a combination of constraints with both less than and greater than. Also, it indicates an infeasible solution. So, let us see what is an infeasible solution first. In the previous problem, we have discussed that whenever there is a common region, you have plotted one constraint and another constraint you have plotted, and you have observed that this is the common region satisfied by both the constraints. Whenever we have a common region for satisfied by all the constraints in a given LPP, we call that as a feasible solution. Whenever the other case is nothing but you have plotted the given constraints on the graph, but we have observed that this is the region satisfied by the first constraint and this is the region satisfied by the second constraint. So here we clearly observe that there is no common region for both the regions. In such a case, we say that the problem has an infeasible solution. That is, when a feasible region doesn't exist, the solution we get is infeasible solution. In graphical solution, it is found that when one constraint is of less than or equal to type and the other constraint is of greater than or equal to type, and these two cannot produce any common area in the first quadrant, it indicates an infeasible solution. Again, I am repeating, in a graphical solution, if it is found that when one constraint is of less than or equal to type and other one is of greater than or equal to type and these two cannot produce any common area in the given quadrant, that is the first quadrant, we say that the problem has an infeasible solution. Let us solve this to know more about the infeasible solution. Following the similar procedure, here first look into the constraints. Here in the first problem we have all the constraints are of less than or equal to type. In the second one we have all the constraints of greater than or equal to type. Here both one is of constraint greater than or equal to type and the other is of less than or equal to 1. This is constraint 1 and constraint 2. Likewise the previous problems, let us express each constraint as an equation and find out the ordered pair. I think you know well about this. Here the ordered pair is 12, 12. Here also put x1 is equal to 0, you will get 3x2 is equal to 60, which implies x2 is 20. If you put x2 0, you will get 2x1 is equal to 60, which implies x1 is equal to 30. What is the ordered pair here? 30, 20 is the ordered pair here. So let us again plot these two constraints on a graph with suitable scale. Here take one of the variable on x-axis and other on the y-axis. Here you have you can take the graph with a scale like 5, 10, 15. You can consider what is the scale on x-axis is 1 centimeter is equal to 5 units. On y-axis also 1 centimeter is equal to 5 units. That is 5, 10, 15, 20, 25, 30, 35. Here also 5, 10, 15, 20, 25, 30, 35. What is the first ordered pair we have? 12, 12. I think approximately here you will get 12 and another 12. Let us join these two to represent the first constraint. This is the first constraint. So what is the nature of this constraint? It is of less than or equal to type. I think you need to shade the area towards the origin. Okay, what is the second constraint? What is the ordered pair here? 30, 20. So here you need to locate 30 and here 20. Now join these two to represent the second constraint. What is the nature of the constraint in the given problem? It is of greater than or equal to type. So the area you need to shade above the origin. So one constraint is of less than or equal to type. You have calculated the ordered pair and located the 2 points on the graph. Join these two and shade if it is of less than or equal to a type, shade the area towards the origin. If it is second constraint, you have located on a graph and it is of greater than or equal to type, shade the area above the origin as it is of greater than or equal to type. So we observe that there is no common area which is satisfied by the two constraints. There is no common area which is satisfied by both the constraints. So it indicates an infeasible solution. So there is no feasible solution, or there is no feasible solution to the given LPP. So this is the third case. Okay, thank you.